Hello, let's have a look at angles. Angles are created when two lines meet or cross at the vertices, or in other words, the corners of the shapes. So here we have the vertices in red. We have four sets of angles here. Can you name them? So the smallest one, or the cutest one, are called acute angles, and they're less than 90 degrees. If they're exactly 90 degrees, we call them right angles. What about if they're a bit bigger than that? We call them obtuse angles, and these are between 90 and 180 degrees. If they're bigger than that, we call them reflex angles. So those are larger than 180 degrees. Let's have a look at some examples. So this one here, we can measure and see that's 40 degrees. What would you call it? It's called an acute angle. What about this one? This is, as you can read it, it is 150 degrees, which is between 90 and 180. So we call it obtuse angle. What about this one? It is 340 degrees, which is way bigger than 180 degrees, and it is called reflex angle. Now this one is exactly 90 degrees, so it's called a right angle. What about these two? Are these angles? Yes, this one here, which goes across a straight line, is called a straight angle, and it's exactly 180 degrees. And if it goes all the way around a point, or revolves around the point, it's called a revolution, and it's 360 degrees. Now, angles that go around a whole point add up to 360 degrees. So for example, if the grey angle is 40 degrees, then we can see that the peach angle can be worked out by doing 360 take away 40, which is 320 degrees. Let's try another one. So here we have part of the circle to be 100 degrees, so the rest of it will be 360 take away 100 degrees, which is 260 degrees. One more. So this angle has 260 degrees covering the majority of the part, so the leftover from the 360 would be 100 degrees. Angles that add up to 90 degrees are called complementary angles. So for example, here we have two angles that add up to 90. One side is 50, so the other side is 90 take away 50, 40 degrees. Or this one, for instance, we have two angles that add up to 90 again, complementary angles. So one is 25, so the other one must be 90 take away 25, which is 65 degrees. Complementary angles add up to 90, supplementary angles add up to 180. So this is a supplementary, so these two are supplementary angles. So one is 50, the other one must be 180 minus 50, which is 130. Let's do a couple more examples with supplementary angles. Here we have part of it to be 70, then the other side would be 180 take away 70 is 110 degrees. Here we have 140 degrees, which means the supplementary angle to that would be 180 take away 140, 40 degrees. Here we have 30 degrees, a right angle, which is 90 degrees. So 30 plus 90 is 120. So what's left over? We have 180 take away 120 is 60 degrees. Down here we have 40 and 20, which is 60. So 180 take away 60 would be 120 degrees. Let's have a look at these two lines, how they cross like this. When this happens, we notice that if we look at the blue and the yellow angle, it adds up to be 180 degrees. And if we focus on the pink and the yellow, we also notice that it also adds to 180 degrees. So what can we say? That means the blue angle and the pink angle, so A and B, are exactly the same. These are called vertically opposite angles, and yes, they're exactly the same, or they're equal. So when we see angles like this, separated by these two lines, vertically opposite, they will be the same. So if the blue angle is 35 degrees, then the pink angle will be 35 degrees as well. Let's have a look at this example. Well, we can see that there's one angle given to us, but we can work out the other three angles because we know from supplementary angles that the pink angle and the peach angle adds up to be 180 degrees. So if that's 130, then that would be 50 degrees. 180 take away 130 is 50 degrees. Now from vertically opposite angles, we can see that the pink angle and the blue angles are equal, so that would be 130 degrees. And again, from vertically opposite angles, we can see that the peach angle and the yellow angle are also matching, so that's going to be 50 degrees also. So here we have an example where we have to be careful which lines we're looking at. So we have one straight line here and one going across there. So the vertically opposite angle is x and the 30 plus 50, or in other words, 80 degrees. So the 80 degrees is equal to x. So x is 80 degrees. What about this one? Okay, we're looking at that line over there and that line over there. So these three angles is equal to that bottom angle. These three angles are vertically opposite to the pink angle. So the pink angle is 150 degrees, so we know that 25 plus x plus 50 is also going to add up to 150. So in other words, we can do 150, take away 25 and 50 to give us x. So 150 take away 50 is 100, take away 25 is 75 degrees. Next, we're going to look at parallel lines. These are the lines that have the same distance all the way across, so they never ever touch. We represent these parallel lines with these arrows, and if there's more than one set, then we put double arrows. So the red lines are parallel and the blue lines are parallel. Now, if a line crosses these parallel lines, it's called a transversal line. And when we do so, we create very interesting angles. I've labeled them here A, B, C, D, E, F, G, H, so that we can talk about them. Let's have a look at these four up here. Now we notice that A and D are vertically opposite and C and B are also vertically opposite. So they're equal, and that's why the same color in this diagram. Now we also notice that these are also matching with the angles at the top there. Let's name these. So we can see that the angles that are corresponding or identical are A and E are corresponding and they're equal. We can see that B and F are also corresponding, and C and G, and lastly D and H. So corresponding angles are equal, and sometimes you might see them with that diagram in the textbook. The next set of angles I want to discuss are alternate angles, so alternating. So for example, we have here C and F are alternating angles, and are they equal? Yes, they are, because remember, so C and B are vertically opposite, so they're going to be matching, and F and B are corresponding, so C and F must also be the same. So alternate angles are also equal. Which other alternate angles can you see? We can also see E and D are alternate angles. In the textbook, you might see them represented like so. And lastly, co-interior angles. Co-inside, co-interior angles. That is C and E. What do they add up to be? Are they the same? So we can see that E and F add up to be 180 degrees because they're on a straight line. And we can see that C is an alternate angle to F. So these two are the same. So what happens to C and E? Well, if E and F add up to be 180, we can see that E and C add up to be 180 as well. So co-interior angles are not equal, they add up to 180 degrees. Can you see another two co-interior angles here? D and F. So these two also add up to be 180 degrees. So a quick recap, corresponding or alternate angles are exactly the same or same value, whereas co-interior add up to be 180 degrees. So a quick recap, corresponding and alternate angles are equal, whereas co-interior add up to be 180 degrees. So let's have a look at this example. Are they corresponding, alternate, or co-interior? These two are corresponding, so A is going to be exactly the same, 110 degrees. What about these two? These are alternate, so B is going to be equal to 40 degrees. What about this one? These two are also corresponding, so C is also 130 degrees. What about these two? These are both inside this section, or in other words, co-interior. So they're not exactly the same, and you can see that D is bigger than the 50. They add up to 180 degrees. So D plus 50 is 180, or in other words, D is 180 minus 50, which is 130 degrees. There's quite a few words to revise, so I recommend that you watch the video again carefully and write down all the key words. That's it for me today. See you next time.